So hello everyone, I'm Daxin from Vienna PM and I have a module comparison. This one is new. Isn't on the synopsis, but I thought, hey, let's do one more. Hopefully my criteria I've chosen are also useful to you. I know they're subjective, but if we think alike, then it should be of use to you. So, quick overview. I want to get results quickly. I start developing mostly by copy-paste from the synopsis, trying out the stuff there. And I can look at the tests and figure out how stuff works. And since there are so many different parsing libraries just for Perl, it takes a lot of time and effort to pick out something that is suitable and that works. If there are problems, I want to be able to solve them with public documentation, not only contained within the module, but also external resources. At least I shouldn't need to pick someone's brain in person or something like that. And also I want to be able to look up in documentation how to express epsilon or empty production or the empty string. This is different words for the same concept, and this shows up in most grammars, and I need to know how to express it or how to write it. And is the parsing library useful in the general case? I have two basic expectations. First one is if I feed it the correct input, then it must succeed. It must not fail. Yeah, you're laughing, but you will see. And the second one is I get a parse tree back. So not only must it be tree shaped, but it also needs to be annotated. The nodes need to know or need to tell their own type. So I don't only want to have the content, but also the type, what it is. And once I have a tree, I can transform it with Perl or whatever. This is the most basic thing, the baseline. So then instead of the old tired arithmetic operation example, the hello world equivalent in grammars, we will use a much simpler example grammar with only 3 rules, details later. And parsing libraries have many more advanced features, but I don't need them yet. For example, many parsing libraries offer to mangle the tree for you at parse time, but I don't want it. I just want to say parse, then I get the tree back, and then I can mangle it myself later. And if the parse does not succeed, I want to have a proper error message. I need to know why it failed, and optionally what should come next in the parse stream. But that's extra on top. At least I want to know why it did not succeed. And using a standard grammar, you've seen yesterday the lightning talk, how useful it is to have a lot of available grammars written in the Antler language. And with standard grammar, I mean grammars, or published by a standards body. So there are 2 standard bodies which publish documents, and a lot of grammars exist in these formats. And if you've ever seen an internet RFC, for example, URI or HTTP and something, is full of one of these standard formats, A, B, and F. And reusing these text form grammars is as simple as just concatenating them. Now I want to preempt, none of the libraries can consume standard grammars out of the box. And some of them are justified in doing so because they offer features which are not available in the standard grammars. For example, what I often encountered is the ability of grammars to express, here are tokens separated by a comma, for example. This is not part of either eBNF or ABNF. So that's fine. Let's have a quick look at the candidates. And why they are relevant to us Perl programmers, and all what I'm considering here is fairly recent. Antler 4 is written in Java. In the previous version, in version 3, it had Perl bindings, and now it doesn't anymore, so I'm just substituting the next best thing, which is JavaScript. I have an old mainstay written pure Perl, MLC library with Swig bindings, MARPA LC library with XS bindings, PEGX, a pure Perl module, Perl 6, not a library, but grammars are a language feature built in. The regex grammar is also pure Perl, but built not with Perl code, but with regex code. So it's built on top of features of the regex engine. Here's our grammar we will test modules against. This is a particularly, it's called the torture test, because it is really good at separating the chaff from the wheat, and it's a valid grammar. So good parsers should be able to make use of it, but some just fail and others have no problem at all. So let's have a look at the implementation themselves. Before I go to the first one, let's consider what are productions of these grammar. So this means input which is valid should be passed by a grammar. For example, one is xz, xy. Yes, and the other one is v followed by any number of w's. Okay. Antler. You first, I first want to say this is you're liable to encounter Antler if you search for parsing toolkit, because there's a huge ecosystem around it, a number of books, developer tools, and out of the box there's also a nice developer experience. So many people use Antler. Let's see how it stacks up. You write your grammar in this special format here. Then you take this grammar file, output some JavaScript files, and then you get a parser which you can load. You can see this follows the Java conventions, and it's quite verbose. All the other ones are comparatively shorter. So in the end, eventually you get a tree. As I said, nice out-of-the-box experience, because it also comes with some test stuff which can output directly from the input in this kind of form. There's also a GUI toolkit which shows you the parse tree. This is not the one which fits to the example, because when I tried it, this segfaulted Java 9. So I was just taking a different one, of the web. The first sentence of the documentation is Antler 4 takes whatever you give it. It just doesn't give a crap. Yet it can't parse the grammar. And the JavaScript code was actually for the Hello World example coming with a with the documentation. So that's a failure. IAP, which means extended yet another Perl parser, has lots and lots of documentation, which is a good problem to have, because you can always ignore too much documentation, but you can't work with too little documentation. You see, the workflow is like the parsing worked back in the C days. You also write a separate file which looks like that. You can straightforward simply translate the grammar. Then you compile this one, and then you get a module file, a modulino. So this means it works both as a library which you can load, or you can execute it from the command line and feed it input from the from the command line. By default, you get no output, just parses. So you have to pick up the results and put them in a tree-like structure. Not in a tree-like structure, but you have to capture the content and annotate it yourself. Could look something like that. And the output of that will look like that. The first case, exercising the rules A and B. Get a nice tree structure. I used indentation here to make the tree obvious. And the other case, produces a nice tree, and it will give you both the content and the type. So that's what I wanted. When parsing fails, then you get a great error message. It says here I stopped at this this string or this token, and I expected one of those instead. So that's nice. If you need debugging, there's a tutorial contained in the documentation, shows you how to enter debug mode. And the state machine, which is underlying the parser, can also be dumped into a human readable form, and then you can look what is the opinion of the parser, how it interprets this grammar. And you can use this to find a mistake if you've made one. Hammer is a C library. Its packaging is quite unperlish, difficult to install. I never said make install, I'm just using the blib directory it produces. Interface is very tedious to use. We will see in the example just coming up. There's no special syntax, unlike the grammars we have just seen before. Just lots of verbose function calls. For example, this rule here, our B rule, looks like that. Here's an alternation. It's equivalent to the choice function. And there's a sequence of rule A, followed by a character X, followed by a character Y. And the alternations between this sequence and a rule named C. So these are just subroutines defined elsewhere, you see? And then we want to capture the content also, so we have to wrap it in an action, and then this you have kind of seen before. So, but this doesn't even handle the white space yet. Now imagine this, and every single subroutine also needs to have a white space sensitive wrapper or something like that. You get the tree, yeah, but it's not annotated. So, as I said, you need to have these action things around your functions. Have to do this manually. And surprisingly, order of alternatives matters for some reason. I've just found this out by experimentation. For example, this is one part of the rule A, I think. Yes. Where it says empty production followed by a sequence. And this is an alternative between these two. This doesn't actually work. It will not produce a result. But if you switch it around, so the choice is between first the sequence and then the empty production, this actually works. And this is quite surprising to me. And then you have something like the rule C, which contained itself. And you can't actually write in Perl subrule C and then refer to it itself. I mean, for normal functions, there are ways around it. You can pre-declare the function. You can also use in 5.16 and following the under sub keyword. But this doesn't help us in this specific case. So, and this toolkit provides this workaround instead. Put this in a variable and then use this function to bind it to itself, and this is super tedious. Yeah, I don't want to actually write this manually. The output then is as expected. This works nicely. This is missing the rule C annotations. You can see B worked, but C did not. This is because I do not actually know where to put a hammer action here. I can't put it here. This has no effect. And I can't put it here because then Perl will say cannot bless a non-ref value. The single and sole error message is parse failure. If something goes wrong, parse failure. That's all. It actually uses the XS function Perl croak, so it will tell you parse failure at line blah in your Perl program, but this does not help you in any way. The parse fails, you don't know why, and debugging is also impossible because it's a C library and it does not contain any debugging helps by itself. So in the worst case, you have to sit there with a C debugger and step through the code. No, I was thinking the same. So that makes it unsuitable, I think. MAPA. Also a nice parsing toolkit. This is how you work with it. Has a little bit of ceremony, but not as bad as the Java stuff we've seen before. Here's the text description of our grammar starting in a here doc. You can see this is the usual stuff you've seen before. This is some some more configuration options. And once you have created your grammar, Then we loop over our input, create a recognizer from the grammar, read some input, and show the output. Okay, this just works. It's easy to get the tree like we wanted. Now we've seen this a couple of times. This is how it should look. Now you can take the tree and transform it. Decent error message. Will show you the position where it failed and what it found, but it won't tell you what is supposed to come next. But it's at least a nicer. Debugging can also be enabled by enabling trace mode. I've put it here in my example code. And the only negative thing I have to say about MAPA is that some of the configuration is part of the grammar and some is in the Perl code, as you've seen before. Like these couple of lines, they could as well be just additional keys in this constructor here. Okay. Next one, PEGX. Documentation is a bit on the sparse side. But at least it's enough to get you started. You can copy paste the synopsis and go from there. It handles white space by you have to insert some special shortcut tokens into the grammar, which then consume the white space. I didn't bother with it. Instead, I'm just feeding it once again the input without any spaces in between. Grammar is straightforward. And the algorithm is the same as we've seen before. Loop over the input, create a recognizer, let's enable debugging, and then show the output if it exists. Otherwise, catch the exception, show the error. Making a tree is supposed to work by subclassing the tree class here, but I couldn't make it work. It has one single method in it called get_rule, but if you override it, it just doesn't receive any data in it. I don't know why. So parsing doesn't work. Here with debugging enabled, it will error out of the recursion. Looks like that. And it will say at the end, deep recursion, 100 levels. Yeah. And error message, if you feed it invalid data, looks like that. It's really nice. Failed for some reason at position blah blah. And here we see what's coming. And yeah. Next one, Perl 6. Really nice interface, well designed. Instead of having the grammar in text form, we use keywords available built into the language, and you have to explicitly name the starting rule, which is called top. And again, the translation is straightforward. And if you parse something, you get an object back. And the bits are just dangling off. You can traverse this tree-like object with its methods instead of a plain data structure, but it works the same. And the result of parsing this and this is then here serialization of the match object, which is returned from the parse method. And the other one doesn't actually finish, so I have to interrupt it. There's an infinite loop if you want to parse this input. And you get no warning at all. No recursion warning, no error message.
We consider left recursion a bug in the grammar.
Say again, please?
We consider left recursion to be a bug in the grammar.
Yeah, Larry said it's Perl 6 considers considers left recursion a bug in the grammar. But the point of the shootout is parsing toolkits should accept any context-free grammar. And yeah, when the parsing fails, you get no error message. Instead, it says nil, which is the return value of the parse object. And debugging is also not built in, but you can install an additional module and then trace or step through the grammar as it executes.
There's modules for error.
There's modules, nice, yeah. So. Last one, regex grammars. Also a very lovely minimal interface, very little to get wrong. And the grammar also distinguishes between tokens and rules, as we've seen before in Perl 6. And I think this is the best way to handle the white space problem. Either you can do it declaratively, like we've seen before in Adler and MAPA, which just says always skip over stuff. But this is a more fine-grained approach, and also gives you a visual distinction between stuff which is white space sensitive or not, rules and tokens. Then the parser is defined as a regular expression. It comes with its own DSL defined within this expression here. And once again, we loop over our input, use the match operator to parse, and if it was successful, we can find the parse tree contained in this hash, in the result hash. Okay, and output looks like this. A kind of different tree structure, but it's semantically equivalent to what we've seen before. Instead of blessing, it annotates the type as a key thing. So this difference does not matter in practical terms. And again, the second example incurs an infinite recursion, but then you will get a warning or an error. I don't remember quite. I'm saying use strictures anyway, so it will be fatal. Will abort here with an infinite recursion. Cause of the error is not the error message, but the cause of the error. What was causing this infinite looping is actually documented, and this tries to be helpful, and this is to be commended. Often documentation does not mention possible problems at all. You get also no error message when a parse fails, so then the bind operator and the match operation will just fail, and you also don't know why it failed. And if you enable debugging, which is also easy by just uncommenting these two lines here, you will get a nice visualization of the backtracking with indentation. So the first part is how many minutes? I'm over 2 minutes, okay. Visualization, and it shows you the backtracking here in the left. So in the summary, important part is, does it parse any grammars? This is the important stuff. And as of now, users can make an informed decision what to use, and I hope this module comparison saves some time for some people. I see this as a problem in the documentation, and the modules should say beforehand, by the way, we parse not all kinds of grammars, but here are the shortcomings, and then one can make an informed decisions. Yeah, I don't care about the edge cases. I like the module because of its interface or whatever. But as of now, we have no other way instead of make a trial and error. And I want to change this, and I want to add the documentation. So any volunteers for this? For helping me? It's not difficult, just time consuming.
Documentation for what?
Yeah, so that you can read in the first paragraph of the module. This kind of technology is underlying, and these kind of grammars are acceptable, and you will run into trouble if you try these kind of grammars. But the point is, with MAPA, you can feed it any grammars. It actually works with anything you throw at it. Always has meaningful error messages. Debugging is solid. It's also fast because it's written in C. Makes guarantees of its worst runtime behavior. So I recommend MAPA for parsing anything. And because of my high expectations, the biggest disappointment is Perl 6. Failure mode is just hanging, no warning at all. When I showed this grammar to the IRC crowd, nobody seemed too particularly concerned that I was able to hang Perl 6. Yeah. And another thing, you can't parse octets, just strings. You will get this error message if you try to parse a buff or something like that. Yeah, that's less than awesome. Even worse than that. In Perl 5 you can switch around. You can use another regex engine if you want. You can just say use RE namespace blah, and then you will get a different implementation at runtime. I don't know whether that's possible in Perl 6.
It's trivial.
It's trivial. That's great to hear. Yeah. Until then, here's a consolation. A binding for libmapper in Perl 6. Currently not working. It's up for adoption, this module. And that's all. Thank you for your patience.